So the question that came in here is, what are SQL Server isolation levels and how do they impact my data? Well, I want to change my screen here to display this little chart. So what are SQL Server isolation levels? Well, isolation levels are how SQL Server controls transactional interaction. And keep in mind that on any SQL Server with any kind of a load, you've got lots of people running queries. And if you just had it so everybody could be modifying the same table at the same time, you'd end up with a lot of data corruption kind of issues. So SQL Server has these isolation levels designed to sort of impact the overall visibility or availability of data in the tables. So the first one I want to cover is what's referred to as read uncommitted. And that's one of those that when people put the no lock hint on a query, read uncommitted is very similar to no lock, but read uncommitted is doing it on a transaction level rather than a single table level. But what read uncommitted means is that I want to read data whether or not it's been committed in a transaction or not. And it allows for what are called dirty reads. And dirty reads are reads where the data is currently changing, and what you're seeing there may not be the final outcome for when the query is completed. You're seeing uncommitted changes that by uncommitted, it might mean that they're going to be rolled back and they may not actually exist. So you're getting dirty data there. And with that, you can also get phantom reads. And there's a lot of options to get phantom reads, but phantom reads are basically where you query a table and say how many of this is there, and you query it again later and it might change. Phantom reads are not nearly as bad as dirty reads, but you get a very high concurrency in that with read uncommitted, you can have a lot more people running without any kind of conflicts. But the data consistency that you run into there is very low, meaning that you may get inaccurate data. There may be some queries that you run where the same row shows up in the result set multiple times. That can happen if a page split is going on or if an index is being rebuilt. So read uncommitted is one of those that if you're in a situation where performance is more important than data accuracy, that might be an okay place to use read uncommitted. And let's say it's something like your favorite social media platform where you're looking at comments, and if one user viewing the post sees a slightly different set of comments for a minute or two than another user sees, well, maybe read uncommitted would be okay for that kind of situation. But if it's something like me, I want to go look at my bank account balance and I'm seeing data that's not entirely accurate, that could be really confusing or really disturbing. And so read uncommitted isn't good for situations where you're concerned about the data consistency. Okay, so the next isolation level is read committed. And read committed is the standard default on SQL Server. And what this says is that I'm going to only read data on my query that's actually been committed. I'm not going to read data that's changing, and I'm not going to read data that's that somebody might possibly roll back on another transaction. So with that, you don't get any dirty reads with read committed, but you still can get phantom reads, meaning the data can change over time. With that, the concurrency, it's not as big of a throughput as read uncommitted, but it is pretty good overall, and the consistency is pretty good overall as well. So read committed works pretty well for most people most of the time. Then we run into repeatable read and serializable. And these are two different isolation levels where they basically both ensure that once data is read, that it can't be modified by another transaction. But the difference between repeatable read and serializable is that serializable makes sure that the entire data range being accessed is being locked. Now, I often equate serializable being like traffic. And if you live somewhere where there's like 10 lanes wide on the highway, like Los Angeles, and you've got 10 lanes there, you can get a whole lot of traffic, assuming the traffic's moving. You can get a whole lot of traffic through on that highway. But if something happens like a presidential motorcade or the Pope shows up with the Pope Mobile or something like that, where they shut down the highway for these special case uses where nobody else can use that highway at the same time, that's kind of what I think of with serializable. Serializable is a way of saying in the database, anything that's touched on this query completely lock it and make it so nobody can touch it, change it, or read it until I'm done doing what I'm going to do here. Serializable is one of those things I've seen in a lot of cases where somebody accidentally turns it on. And although it does give you the absolute highest level of consistency, very rarely have I ever seen a situation where that level of consistency is actually going to be a good thing compared to the performance that you lose. One client, actually, I shouldn't say one, multiple clients that we worked with here had a situation where this accidentally got turned on in their, the web.config file in .NET, where it was defining your SQL Server connection. They accidentally turned on serializable, which meant that everything was basically running serializable. It only meant that one query could be running at a time on all those tables that were being touched by that query. We're able to change that back to the default of read committed, and that was a night and day performance improvement for the client. Next, I want to talk about snapshot and read committed snapshot isolation level. And snapshot is one of those that basically takes a snapshot of your data. Excuse me. With snapshot and read committed snapshot, they both have a pretty big impact on your tempdb load. But read committed snapshot isolation level, or RCSI, most of these other things are isolation levels that you turn on a query by query basis. But read committed snapshot isolation requires you to turn it on a server basis or a database by database basis, so that all queries going forward at that point can then use that read committed snapshot isolation level. And what read committed snapshot isolation level does, this is really cool. It basically keeps a copy of data that's changing in tempdb, so that when you read, you're never getting dirty reads, but you're never being blocked by people changing the data, because you're able to look at what that data looked like before it was being changed or before those open transactions were started. We worked with clients on this. In fact, I talked to one just a couple days ago where 2 years ago we turned on read committed snapshot isolation level for them, and it took a system that was getting stuck or blocking almost every single day, multiple times, to it's been running beautifully for almost 2 years. And now we did have to increase some things around tempdb and do a little bit of extra checking on a couple things around read committed snapshot isolation level, but that's one of those that if you have a lot of locking and blocking, it's one of those things you can consider taking a look at. So my recommendation here is that 99% of the time, keeping your SQL Server in the read committed snapshot isolation level or the default is going to be fine. But for those outliers, that 1% read committed snapshot isolation level is generally the best option. And very rarely do we come up with scenarios where the other ones aren't worth using. So hopefully that answers the question on what are isolation levels in SQL Server.